Hello everyone, and welcome to the next topic I want to look at within the overall section, excuse me, which is Android architecture components. Okay, so again, the agenda, the way I'll break it down is as follows. We'll have a quick introduction, again, just put things in context for you. We'll have a general overview of the architecture components, and then I will briefly look at each component in individually, okay? And then we'll just have a kind of a quick conclusion again, okay? So just to again put things in context for you. So in the beginning, Google weren't recommending any particular design pattern and approach to mobile app development, so it was difficult dealing with certain common use cases. So again, they weren't pushing any particular design pattern like the ones we would have looked at the previous section, but more often than not, it ended up applying the MVC, or the model view controller, mainly because there were simple enough apps that were getting developed at the time. Okay, but as applications got more complex, they still didn't push a particular design pattern to focus on. So as I say, it was difficult dealing with certain common use cases. Something like your configuration changes and even rotating a screen would actually restart your whole app. Okay, so you as a developer had to be able to deal with that, and that was quite tricky within the MVC world. And if you didn't, if your app wasn't written very well, you would end up, your app could crash on something as simple as a screen rotation. Another issue there, sharing app data or sharing app state data between fragments and activities was also tricky. So again, working with the life cycle, trying to keep data in sync, and again, if as you know yourselves, each activity could be going through its own separate life cycle, and if you want to share that app data between those fragments and activities, all that was hard to manage. Okay. Now, while these difficulties are not insurmountable, the fact that they cropped up in so many common scenarios had a negative impact on the developer experience in Android. Okay, so ultimately, the developers got it done. They made sure that when we did rotate the screen, there was fixes there. There was ways to make sure that the apps didn't crash, but it was all extra overhead on the developers. Okay, and again, they just kept kind of crying out to make things easier, and getting on to Google about it. Okay, now because of all that, right, at Google I/O 2017, Architecture Components version 1 was launched, and it was a big deal back then because it was the first time in over a decade that Google officially came out and said this is how you should build an Android app. So for, as I say, for launched in 2007, so for 10 years, even though Google kept changing and adding to the framework itself, adding to the libraries, bringing in all these new features, they never really said, look, with these new components now, this is probably the way you should build an app because this is the way they're all supposed to work together. They didn't do any of that. So when they decided to nail it down essentially and say, using these particular components, this is how you should build an Android app, right? So that's why it was actually quite a big deal in the developer world, okay? So Google started to shift its philosophy by providing architectural solutions for common problems that every Android developer faces at some point. So all these common problems that would be cropping up as the applications got more and more complex, Google tried to provide solutions for that. Okay. Now, these solutions made up the first release of the Android architecture components, which were a set of libraries guided by the separations of concerns principle, making apps more modular, test-friendly, and easy to maintain. So again, if you go back to the previous section, looking at the design patterns, all about this decoupling, the separation of concerns, separating out those components, so that they were using those principles, and that was at the forefront when they were bringing in these new components. Okay, so the next point there, lifecycle, live data, room, view model, and data binding were all part of the initial architecture components release. And again, I'll look at those in a little bit more detail later on. But we're going to be looking at very regularly our live data, our view model, and data binding in later sections. So that's going to start cropping up, and that they are fundamental components within the MVVM. And again, I'll probably talk about that in a minute. Okay, now So bundling Jetpack, there's a lot more to offer. So that's something you should be getting your head around as well, and becoming familiar with, is Android Jetpack. Okay, just to kind of show you their own graphic, what they'd have up on their own site, the different kind of components within the overall Jetpack. So to have it split into separate categories: architecture, UI, behavior, and foundation. And if you look at the section themselves, so within under the architecture umbrella, you can see here, look, there's our live data, there's our view model, we'll be working with that. There's also life cycles, there's data binding. So again, as I said, this section is very important going forward with the rest of the material that we're going to cover. It's all driven by this new kind of the architecture components. Okay. You can see there under foundation, look, Android KTX, Kotlin extension libraries. So we can probably look at that a little bit as well. In our UI, you might want to investigate some of that yourself. Different animations, transitions, that does kind of crop up under the navigation component, which we would have covered, and which also ties in there with fragments as well. We have our look at different layouts, all the rest of it. And then under behavior, if download manager, look, media and playback, permissions, we'll be looking at that. And we have a little bit on sharing, and again kind of slice it there as well. So if you want to, you can go off and you can have a look at some of those other components within the overall Jetpack library. But as I say, we'll be focusing mostly within the architecture section, architecture category. Okay, so the official kind of blurb from Google, why use Android Jetpack? So they're saying follow best practices. So again, just ways to try and help the developer build good, robust apps that will enable, as I say, fewer crashes and less memory leaks. Memory leaks is a big one, and again, as we'll see now with the architecture components themselves tied with MVVM, it really kind of handles those issues and deals with those in a very nice manner. Okay. Another reason there, eliminate boilerplate code. Again, you rather than having to write all the stuff yourself, write all the code, you can bring in the dependencies and just go and use the components themselves. So it's more about understanding what the components can do for you and when to use them. And again, that's all part of Jetpack. And the last final one there, final from their kind of official site, reduce fragmentation, which is, again, because of the way Android has gone now at the moment, reduces complexity with libraries that work consistently across Android versions and devices. Because now Android is so pervasive on so many different types of devices, and there's so many different versions of Android still out there, that Jetpack tries to, as I said, reduce complexity and keep it very consistent, so that if you build for Android 10 and you've been building using Android Jetpack and using the Jetpack components, in theory it should work seamlessly on previous versions of Android. Okay. And again, look, you can get a lot of it there on the developer on android.com/jetpack. Okay, so if we look now at the specific Android architecture components that Android have developed and are encouraging developers to use in building these complex Android apps. Okay, so according to Google, the Android architecture components are a collection of libraries that help you design robust, testable, and maintainable apps. These components help solve many of the problems that Android developers face on a project. So again, simple ones like screen rotations, sharing your data, your memory leaks, trying to cut down on crashes. It helps create a clean and easy. It helps create a clean and easy to maintain architecture such as MVVM, with the goal of taking advantage of all the capabilities of the Android framework and its structure. So as you can see, they're going to use basically the same terminology. So within the model view model, there's a view model component within these architecture components that would be used in exactly the same way. So even though MVVM is a design pattern, Google are directly adopting this for building Android apps and have developed specific components, these architecture components, to allow a developer to apply that MVVM pattern. Okay, and MVVM is what Google are recommending. And again, that's another reason where we're going to actually build it and apply it as well. Okay, so we'll take a brief look at those components. Okay, just break them down for you. Okay, so first one there, life cycles. So manages activity and fragment life cycles of our app. Survives, this is important, survives configuration changes, avoids memory leaks, and easily loads data into UI. A big problem in prior to these particular components, as I say, was something as simple as the user rotating the screen. What that caused your activity to shut down and restart again. And if you didn't have proper code in place to manage that kind of configuration change and that screen rotation and running through the life cycle, it could crash your app. You could lose, as I say, you could have memory leaks. There's data getting lost. And using the lifecycle component does away with all that. So you can actually keep track much more effectively and efficiently the life cycle within your app and how data is managed within that life cycle. Okay, next one there, live data. So this notifies views of any database with quote database changes. You can use live data to build data objects that notify views when the underlying database, now when we say database, any kind of your raw data, whatever you're linking into. So generally what we will do is we will use live data and certain types of live data to manage the objects that we want to store, and that then will tie in with the life cycle, so that we're not going to lose the data if there's different states within the life cycle. So if an activity restarts, whenever it's paused, if it resumes, our live data coupled with the view model, we'll be able to manage our data and cause kind of automatic updates to the view. This is a really nice feature as well, is that we can the term is observe our data. Okay, so no matter where it changes within our app, we can ensure that that data is automatically updated. So we don't have to go and refresh, we don't have to manually check ourselves. This will be done automatically within and using these architecture components. Okay, and just following on to the next one there, the view model manages UI related data in a life cycle conscious way, stores UI related data that isn't destroyed on app rotation. So we will see a lot, and even if you do your own kind of little bit of research on MVVM and these architecture components, you will see a lot of usage of live data within the view model. So those two components together can ensure no memory leaks, can ensure automatic updates, can ensure data isn't destroyed, isn't lost. So again, makes for much more robust, much more scalable apps, okay, and easier to manage. Some of the next ones there, data binding, again we'll be looking at this as well, helps in declaratively binding UI elements in our layout to the data sources of the app. So we don't have to write code in our activity or in our controller, so to speak, to update content, update data in the layout. We can, using XML, directly bind to the underlying data. So whenever the data changes, the view will automatically change as well. And that's a really nice feature and of this particular component. Other ones there, we have Room. Navigation. Room is an SQLite object mapping library. You may have come across it before. We won't be looking at it, but if you do want to have some kind of a database backend to your application, Room would be definitely a good solution for you. All right. Room also provides compile time checks of SQLite statements. So, and you can even use some of your SQLite, maybe if you're coming from be it Java or even a desktop app, which would have connected to a database, you can bring in those SQLite tables and the table data if you need to. Okay. Next one there, navigation, handles everything you need for in-app navigation in an Android app. We've looked at this in previous sections. The navigation component, really nice component for speeding up and managing, especially working with fragments within your application. Okay, so again, one to recommend. Last couple there, we have paging, which helps in gradually loading information on demand from a data source. You may be familiar with this if you've done any kind of web development. So again, we don't have to load up everything in one go. It may take a long time, especially if you're downloading it from some cloud resource. So paging will give a much better experience to the end user. And then finally their work manager, an API that makes it easy to schedule deferrable asynchronous tasks that are expected to run even if the app exits or the device restarts. So again, would tie in with any kind of cloud-based data. If you want to run something in the background, this work manager component will give you a lot of functions to that you just essentially use, as opposed to having to go off and write all your own kind of asynchronous code in the background. Okay, so just to wrap it up there, quick conclusion: all these libraries will help us write code that's cleaner, faster, more scalable and easier to maintain. But there are a lot of steps to using these components and implementing the recommended architecture. So the most important thing, right, is to try and create a mental model of what is going on and understand how the pieces fit together and how the data flows. So again, you're rather than just diving in and trying to use all these different components, you're much better off taking a step back, hopefully choosing the correct design pattern that you want to apply, and then look at what the architecture components can give you, and look at what those different components do and will allow you to do, and then decide which components you kind of need to use. Now, again, going back to what Google are recommending, is that they are saying to and recommending to use MVVM. So that's why you would definitely be working with live data, working with view model, and data binding, and we will see all those now in our code walkthroughs and in later versions of Donation. Okay, so again, I think I have some references there for you as well. Yeah, similar set of references. Okay, so if you want to kind of have a look at those, you're more than welcome. So other than that, thanks for listening, and goodbye.